Hallo Freunde, willkommen zurück zu .NET API Review. Surprise, we're having a Thursday meeting this week. We aren't really trying to make progress on the backlog per se. Today we're theoretically going to complete 2 issues on tensors. We'll see how we do. Alright, first up, 98862, generic math on tensor primitives. Tanner?
Ja, should be. Toen ik het. Ja. Okay, yeah. So for this one, on tensor primitives, we had previously approved min max magnitude. Um, we missed exposing min max magnitude number. Uh, the intent was to mirror the math surface area over the tensor primitives. And so this is just saying formally going through API review and making sure we didn't have any issues with exposing them.
And the index ofs, we already have similar things on tensor primitives.
Yep.
Index of max and magnitude, and alright, and so these are just number. X and Y are our names.
Yep.
These are your favorites, aren't they?
Just uh, is that the usually destination is the second parameter. So
Yeah, it's that's the order we've got for all of them because they take two parameters. And so destination's the last because there's two parameters that are the sources. That's how we've done all
kind of.
the APIs so far.
Yep. Okay. Just checking for consistency before.
So what does it do? It just the minimum number between what's in the span and the extra value?
That's so the first version is taking a span of X and a span of Y, and it's computing element wise X versus Y. And the second one takes a T, which is a scalar, and implicitly broadcasts it up to the full span. That way you can say pick the minimum between X and 0, and you don't have to do the allocation and everything. That's what we've done for all the APIs.
I see. So it's element wise. It's just, I see.
So I had a question. So presumably the number suffix disambiguates from existing methods that don't use generic math. Is that the case?
No. The difference between max and max number is that max will propagate a nan if the underlying T supports nan, and max number does not propagate nan. It returns the the finite value instead. That is the number. Um, this is the existing convention we have in math, and that's used for on I number and I number base to represent the concept, because it's basically down to, do I return the thing that is a number or the thing that is not a number? And they ended up being this way for historical reasons, but it's also the way that the IEEE spec defines it, and accordingly what other languages have used for their naming convention to differentiate the two.
Thanks.
Alright. Sounds like no substantive comments. Some of these are I number and some of these are I number base. Are they
Right.
correct?
That's the difference. Yes.
Okay. That's all.
Number bases include complex numbers and so aren't comparable. So, uh, uh, but complex numbers can compare magnitudes. So number base includes the min magnitude versions, whereas number includes just it includes the ones that don't factor in magnitude.
Good enough for me. Alright. tensor and supporting types 100924.
Yeah. So this is going to go over a few different concepts. There's a lot of conceptual discussions that has to be gotten into parts. So and there's a corresponding design doc that goes into a lot more detail on the various topics here. To start with, tensors work over. They're effectively an abstraction that works over dimensioned memory. So whereas array is single dimensional, tensors are typically multidimensional, but that also includes single dimensioned data. Because we're working over multidimensional data and because it's being used in things like machine learning, AI, and other scenarios, there is frequently the need to work with large data to reshape the data and to do other operations. So even if you might not have more than 2 billion elements, you might have more than 2 gigabytes of data, you might need to reshape that data into a different form, which would then necessitate more than 2 billion indices in a single dimension for the new shape. Accordingly, that means that our existing types like index, range, span are not sufficient for representing memory like that. So in order to support the move, in order to better support big data, machine learning, intelligent apps, and things like that, we are going to need to define new types that in the proposal are called native index and native range. They exactly mirror the existing index and range surface area, except they use inint instead of int. And they provide additional conversion operators that allow for an implicit conversion from the int-based range and an explicit conversion that can either be checked or unchecked to the underlying index type, thus mirroring what you can do for conversions from int to inint and from inint to int. There is also a question on whether or not we should be, which is related to the next section, which is whether we should also be defining at the same time native span, so that you can have large one-dimensional data over memory that supports more than 2 billion elements. This has come up as in various user requests, essentially ever since span was introduced. We know that there's limitations with span today because if you have a span that contains, like, let's say, 500,000 longs or 250,000 or a 250,000,000 GUIDs, you can't then reinterpret that as a span of bytes because you would have more than 2 billion bytes. A native span type would solve that issue. And so while it's not explicitly called out here, it is a question that we probably want to consider and answer at the same time.
Okay, so the first thing I have is, and I'm looking what the guideline actually says, but basically it's conversion operators bad, named ways of doing things good. It's not that we have to get rid of the operators, but I think we need a constructor that takes an index and then might want a, to index method.
We noted
because
okay,
conversion
yes.
operators are not discoverable. Like
Mhm.
you either
So
it's trivia, you
basically
know it
add
or
an
you don't.
addition-
Yeah.
Add an extra one that's public native index value, and one that's and then to index and to index checked.
Yeah, I don't know that we have a pattern for the checked and not, since that's new, but no, implementation does not match the text implicit operator. Seriously, Adobe. can either search or host, but I can't apparently do both effectively. Yeah, I mean, I assume that a 2 index would be checked always, because you can't get a... Once we added the checked operators, can you think of anywhere that we have... Like, did we add the method for checked and unchecked?
I don't think so. Most of the places we ended up touching were the primitive types, and those have never had the named conversions.
Because, like, does big integer not have to int? It just has the, you have to know it's castable.
I think so.
Okay. Yeah, so the native range can hydrate from a range. Needs an instance to range. Yeah, so I'll see if I can find the guideline to make sure we're being clear, but we can go ahead and start talking about the next aspect.
The next aspect is that we have span today. Span allows you to represent an abstraction over arbitrary linear memory. So whether it's a pointer or whether it's allocated native as an actual pointer, or if it's allocated in managed memory, whether it's on the stack, etc., span allows you to represent all of those using one universal type. In the same way, because tensors are because of the way machine learning, intelligent apps, tensors, and everything else works, we now have the need for similar concepts with multidimensional memory, where we're going to want users to be able to use the types we're defining here in .NET, or also be able to use something that might be produced by another .NET bindings library like TorchSharp or various PyTorch bindings, things in Onyx, things like that. So the proposal is to expose a new type called span ND, where that basically just means it's a multidimensional span. There had been proposals for span of MD instead, specifically for multidimensional, but various people did not prefer that over span ND.
What is the N supposed to stand for, and the fact that we have to ask means ND is not a good name?
It just indicates the count. N is a common placeholder for a number. And so span ND just means this is a span of n dimensions.
In dimensional instead of non-dimensional or multi-dimensional. Yeah, so I mean, maybe that means that D is really the, like, you know, but our guidelines are don't use abbreviations. And but we can bike shed on that.
The guidelines definitely don't use abbreviations, but at the same time, this is one of those cases where it's used in type so much that people would likely find it more annoying and less convenient.
Maybe
overall.
But again, like, I had literally no idea why this was called span ND. So spanend, I don't think is a good name. I mean, maybe everybody else does, but
Is ND like common abbreviation for, so it's just n dimensions, so like multi-dimensional. Is that common in like other APIs and other languages?
Yeah, various other languages use terms like ND or MD, M by N, and other similar concepts to represent arbitrary data. There's not really a consistency around that. Um, N just happens to be the most common, one of the most common prefixes when you're typing out something like n dimensional. Um, if you're just trying to specify that this is a count of unknown, n is one of the most common letters to use there. Uh, for the actual APIs, a span ND has two important pieces. So unlike a span, which only tracks a ref field and as an interior pointer, span ND needs two additional pieces of information. It needs the ref pointing to the starting memory location for the entire slice that you're tracking. It needs to know the length of each dimension that you're tracking, and then it needs to know the stride of each dimension. That way, it knows how to skip memory. For example, if you had a 9x9 matrix and you took a 3x3 slice out of it, the memory in total is no longer linear, because after the third element, it will have a skip to get to the next row. And therefore, you need to track the strides information that effectively says, here's how long each dimension of the underlying allocation is, so I know how to get to the next row once I've hit the end of the current dimension. And so, in general, and the first constructor is actually wrong there. It should be it should include strides. But in general, whenever we do construction, we need three pieces. We need 2 or 3 pieces of information. When it's 2 pieces of information, then it's considered a whole linear allocation. So the first overlay that takes a void pointer and a length. It is assumed that the entire allocation is contiguous, and that the first row, that row 1 ends after the final column of row 0. For example, if it was 2-dimensional. And then there should be a third one that takes both lengths and strides. That way you can correctly compute the the overall slice out of the linear allocation if it is a nonlinear view.
So span also, in addition to taking a pointer, and I think it only takes an SC array instead of array, but span also has constructors that take just a ref. Is that missing from here or intentionally omitted?
It's intentionally omitted. We could provide it for it kind of fits into that comment there of, do we also want overloads for common dimensions, like explicitly a 2-dimensional array or explicitly a 3-dimensional array. In the same category, we would want an overload that takes a 1-dimensional array and potentially a ref t, where you're effectively defining a span ND that represents the overload that takes just a single ref is implicitly treating the length as 1, and therefore is wrapping a scalar. So it's a convenience method for creating a span over a scalar value. And it fits into that, do we want the convenience overloads or not?
guess, yeah, fair enough. The only span that takes a ref takes the single ref. Because a ref will keep the object alive and the pointer will not. I mean, assuming that you only use your span ND within a fixed block, then the fixed block is what's keeping the object alive. But
Yeah.
fair enough.
And I just updated to add the missing overload for the pointer. Since text is clearer than speaking in this case.
All right. Why
Does anyone have input or opinion on whether the convenience overloads are worth exposing?
Not yet. But why are the first group called lengths and strides, and the second are called offsets and lengths?
Because with a pointer, you point to the first element of the memory you want to track. With an array, you can't do that. With an array, you're pointing to the total allocation rather than the initial offset. It's also how span has its two overloads. Span has an overload that takes a pointer and a length, and an overload that takes an array, and one that takes an array, a start, and a length. In that order.
Right. So shouldn't this one have offsets, lengths, and strides? Maybe I don't know what a stride is, so if it's a dumb question.
So a stride is a stride is the length of the previous dimension, essentially. So a regular span always has a stride of 1 because there's exactly one element offset between neighboring values. A 1920 by 1080 image, so 1920 rows, 1080 columns, has 2 strides, one of which is 1. That's the space between the columns. And then the row has a stride of 1080 because there's 1080 columns between each row. If you were to add another dimension on top, then if you were to have like a 2 by 1920 by 1080, then you'd still have 1 1080, and then the other dimension is 1920 times 1080, because you've got that many T entries between each image in so that's how much data exists between each Z dimension effectively.
And are
With
the lengths the size
array,
of each dimension? Are there like the same number of lengths and strides? Sorry, I'm confused too.
Yeah. There's always the same number of lengths and strides.
Okay.
Yeah, you can think about lengths as right, the dimensions of the span ND itself, and so that's one of the things we actually discussed was that naming. But anyways, and so right, length is just the dimensions, and then the strides is the offsets to get to those dimensions.
Yeah, and so
Okay,
the reason
so while not understanding any of that, why doesn't the array one need one?
The strides is the stride of the data is implicitly coming from array. because it's always implicit to the array itself. The actual array tracks what the strides are, so it doesn't need to be passed.
So you're assuming you're not like reinterpreting a single dimensional array as a multi-dimensional array.
Right. If you wanted to do that, then that's you would need to reshape the span. It becomes a conceptually dangerous operation. It's safe in that you're never going to AV if you access data, but if you had something like an image, a 1920 by 1080 image, and you said, well, I want to reinterpret this as a 1080 by 1920 image. Well, if you pass that into another algorithm that is doing something like drawing a straight line in the buffer, that straight line is now going to end up incorrectly crossing what it thinks is a line boundary, and you can corrupt your image effectively, the visual look of your image. And that's actually a common bug that some image processing libraries will end up having when they end up doing unsafe optimizations for perf. So reshaping is it's a core operation that you want to do in many cases, but it's also this conceptually dangerous operation where if you do it, you want to be careful due to the implications of how you're effectively rearranging rearranging what the memory looks like to the user.
So with the first overload that takes a pointer, where you just take lengths, are the strides just like the first length times the second length? Like, is it just like calculated that way? Does that make sense?
Well, so because it's a pointer, it points to the start of memory. So if that was a linear allocation of a 9x9 array, then the typical case would be that the strides would be exactly as you said. They could be implicitly computed from the lengths, and that's what the first overload does. The second overload exists because you might be actually creating a slice of that 9x9 memory. You might be taking a 3x3 slice from the top left corner, for example, in which case the strides still need to match the original 9x9 allocation, while the lengths will be 3-3.
Well, thanks for answering the follow-up question without me even asking it. But yeah, thank you.
Okay, yeah. But then if you have a 9x9 but you want a 3x3 out of the middle, you have to do that in 2 calls?
No, it's still 1 call. Because the pointer would point to the first element of the slice that you're tracking.
Yep.
So it would point to index 2-2. The lengths would be 3-3 because you're still taking a 3x3 slice, and the strides would still be 3-1 because you, regardless of what slice you've taken, there's still 3 elements between whatever column you're pointing on and the same column on the next row. And there's still 1 element between each column. So the strides basically says, here's the shape of the original allocation, whereas the length says, here's the shape of the view that I've taken.
Right, so the strides, I think, would be not a sane number, because the offset from the first row to the second would be 6, and the offset from the second row to the third is 9.
No, it's only tracking the offset per dimension. So regardless of what row you're on, there's always 3 elements between that row and the next row.
But there were 9 before you took the slice. So does the stride say 9 or 3?
It says 9 because you had a 9 and you're going to the next row. It just tracks the number of elements between the current row and the next row. And so the strides are always consistent. And the reason why you always include the one that says 1 is because you can actually do interesting optimizations where you do something like you take let's say you had a 5x4 matrix and you wanted to reinterpret it as a 4x5 matrix. You can do that without having to copy the data, provided you track this what position the stride that's length that is length 1.
Okay, so this to me feels like it's super easy to be talking about a range of memory that you don't understand. So I wonder if we can we have a constructor that takes a span of where you think you're talking about, and then if the math says you can't describe a thing, like your lengths and strides don't make sense within that box, it fails.
Well, I mean, the whole point of this one is it's an unsafe overload that allows you to talk about arbitrary memory.
Fair enough. I mean, I guess if you have your picture in a byte array, then you're calling this one, which presumably will bounds check for you.
Right. The one that's safe and takes an array would end up doing the relevant checks to say, I actually know what the underlying allocation is, and therefore I will do the validation for you. Whereas the one that takes the pointer is explicitly the unsafe one, just like exists on span. It does no validation, it just assumes the user has passed in everything correctly.
Yeah. I feel that this is very much setting us up, though, for Doom, and I think it needs another int or inint of what's the furthest point it can reach from the pointer, because something in here needs to say you've given me gibberish, that this is sprintf and we need s in printf. That's not quite the same because this isn't writing to it yet, but I think the constructor, somebody needs at least an overload that can say this is the limit. If I screw up the math, tell me. Because I don't think I literally don't think I'm smart enough to ever call this.
Is.
So I to me I need a guardrail here of how do I know if I've screwed up my strides or links or the combination thereof.
That would, if you want to ensure you've not screwed it up, that's what calling the first overload followed by slice would do.
Fair enough.
Can this be built on top of span? Sorry, it's the one ask this. Have a span constructor.
We could theoretically have one that converts a span to a span ND. We would have to extract the underlying byref from the span. But you couldn't. But there's cases where span can't represent enough data because it only can represent 2 billion elements.
Okay, yeah.
So it's limited in the same way that array is limited.
Sure, but can we have the span ND capture the ref from a span so that it stays GC tracked instead of put it in a fixed state?
Yeah, so we could provide an overload that took a span of T span and one that took a span of T span and read-only span init strides if a user wanted to reshape it. The latter one is the one that's somewhat dangerous.
Would it be strides or lengths? I assume it would just mirror this, but say span.
Yeah.
Yeah. Chat asked, "Are you missing the word read-only in the type definition?"
For which one?
The thing currently called span ND. Should it not be a read-only?
Oh yeah, that should probably be a read-only struct. Yeah. That should be indeed a read-only ref struct.
And then if we add span here. Is this now a casting problem from an SC array?
It shouldn't be, because C# 13 is getting the improved overload resolution for spans and arrays and stuff.
Okay, like it will have a, it won't make you cast. It'll pick one. I think it'll actually pick array.
Yeah.
Because array is a intrinsic
the new language
conversion
rules is
instead
it
of
should
a.
pick span, actually.
Fair enough.
Yeah, the new language feature is just, it's making span a first class citizen in the language so that it gets the intrinsic conversions that the language allows.
Fair enough.
We then have the common empty property, which just returns an empty multidimensional span. We have the common property is empty. Then the next four properties are somewhat interesting. So up until this point, we've not really had a lot of multidimensional concepts in .NET. Array itself has multidimensional concepts, but it exposes it in a way that we know to be confusing to users. And so, in particular, it exposes length, which returns the linear length of the underlying allocation. It returns long length, which is the 64-bit linear length of the underlying array allocation, which is useful for when the total length of all dimensions is greater than 2 billion elements, which is allowed for multidimensional arrays. And then it has a method named getLength, which returns the length of a particular dimension. Of course, that was all designed 20 years ago, before we had things like span and allocation, the ability to return data in an allocation-free manner. The proposal here is to expose this in a way that we think is more intuitive to developers, gives you access to the data in an allocation-free way. And so in particular, we have the lengths property, which returns the lengths of each dimension of the view that's being tracked. We have linear length, which is explicitly the total amount of data tracked by the view. So a 3x3 would be 9. It's effectively a helper that is the multiplication of all lengths together. We have rank, which matches the terminology used in array. Some other languages also use rank, some use dimensions instead, but it is the number of dimensions that are tracked by the span. So whether it's a 2-dimensional span, so like a 3x3, right, or a 3-dimensional, a 2x3x3, or anything like
lengths
that.
Length.
Then we have the strides, which.
So rank is lengths.length. Rank is the value of lengths.length.
Yeah. Yes.
Yeah.
Yes. Or strides.length.
Yeah.
And then strides, as described previously, is the distance between sequential entries of a particular dimension.
Right. So, going back to the world where we have let's not do things that are actually squares of each other, a 10 by 10 thing, and you take a 3 by 3 slice out of it. The 3 by 3 slice's linear length will say 9.
Yes.
Do we need or want another value that talks about the total encapsulated memory length? Is that useful?
We could have it, but that's not necessarily useful. A name that might be better than linear length might be total length. Just to avoid that confusion on what linear means.
I actually thought linear length was more clear than total length, but I think both are fairly clear.
Yeah, the only real potential confusion is whether they think that linear length means that the entire view is linear, and a 3 by 3 slice of a 10 by 10 matrix wouldn't be linear. And so that's the potential confusion.
Yeah,
But
I see.
linear length was the thing that I think most people's minds jumped to when we were thinking, like, what should we call the thing that represents the total length effectively?
Yeah, like I definitely think that is if I just like flattened out the entire like projection into one dimension, like that would be the linear length, ignoring like whether it was actually contiguous address space. Like, yeah. But yeah.
Right. I just
Yeah, and that's kind of what
wonder if
that's
somebody has
part of
a
what we had discussed in various things, like contiguous versus linear versus.
right. Just if there's I don't know something like paging where you're trying to ask, can I let the last couple of megabytes fall out of the universe yet? Is the thing I would think of why you would want it, because you can figure out where the start is by calling get pinnable reference and turning that into an address, but I don't know how easy it is for somebody from this to get what's the terminal address being represented in this span.
Yeah, and to get the terminal address of any span, you because it's a view of arbitrary memory, you effectively have to um, get the ref to index caret one, caret one, caret one, etc. So you basically have to explicitly get the reference to the last index because it has to be computed.
Fair enough. All right, so we're happy leaving linear length as is.
It sounds like it.
Okay.
We then have a indexer that takes params read-only span of indices. It is worth noting that that this overload in particular, there's a little bit of discussion. Maybe Michael can explain it a little bit better on what it means if a user does not specify all indices. So if indices.length doesn't match rank. There are many different libraries, and this gets particularly more interesting when you're doing slicing, where they basically allow a lesser number of dimensions to be specified, and they may do different operations depending on how many dimensions were specified. Because when you're working with multidimensional data, there's not just a t that you can conceptually get. You can also reduce the number of dimensions. So you could go from, if you wanted to get just a single row out of a 3 by 3 matrix, it's interesting to have the possibility of returning a another span in D or even a span. I don't remember what the prototype had opted to do for the indexer here in particular, though. Michael?
So for the indexer, we're just requiring, in the prototype, we're requiring that the number of dimensions passed in equals the number of dimensions in the span ND. It mostly comes into play when you talk about slicing with ranges, where you get into the more potentially interesting use cases. But when you're only returning just a single ref t, you still mostly need to match. It's once you actually start returning the full span ND in slice that you can hit the more interesting stuff. So I can talk about that now, or we can wait till we get down to slice. Either way.
I think that one can wait for slice. So for this one, then we will just have it. Indices will have to match the rank, the length of the indices. we've not made a determination yet on whether or not a params init array overload needs to also be provided, given that this is itself a ref struct. Though I would imagine that we don't need it in this particular case, even if we did want it more generally for consistency, since languages that have to use ref structs should support params read-only span moving forward.
I don't think this one would need an array convenience one, no. Will index lowering work here? Or does this also need an indexer that takes a span of native index?
So today it would not work because the way it works with regular span doesn't need an overload that takes index, because the language understands how to map index with a member that exposes length. But that only works with single dimensional data right now. The language, there's proposals for taking to the language to improve language support for multidimensional data, including slicing, ranges, etc. That would not be in this release of .NET. That would be the next version of .NET at the earliest. So we probably do want one that takes index here, just so users aren't inconvenienced. But more long term, ideally the language gets the support and it would be implicitly mapped. And so that overload would become a historical artifact over time.
Yeah, I mean, they'd also have to presumably index and range are special cased in these things, and they'd have to special case native index and native range, so that's also going to take even more time. So, I mean, that's an easier change than a language change, but
yeah.
Okay, I've duplicated the indexer to take read-only span of native index.
Okay.
Actually, would that be legal?
We then have the same.
Because that would be. Yeah, you can have two params overloads. It'll. Amusingly, it will stop you from using from calling the indexer with no data.
Yeah, which might actually be goodness.
Yeah. Yeah, I was gonna like zero-dimensional input is always invalid here, I think. So overloading on read-only param span of native index stops that because it then can't figure out which one to call. Cool.
You're gonna like ruin someone's recursive base case. No, I don't know. I don't think so. Especially not. Yeah.
They'll have to pass span of something.empty.
Yeah.
There's a meta question before we continue where people are asking about places that were returning inint and they're surprised it's not newint. Presumably this is things like the length.
Yeah, so I've talked about this before. So there's both pros and cons to unsigned types. .NET in general uses signed types, and over time, languages, even C and C++, have started saying, we used unsigned types here, but it was probably actually a mistake. Particularly when it comes to memory, one of the most important things to consider is that the address space is, yes, 2 to the power of 32 or 2 to the power of 64. But you are never going to be running in an environment where you have access to the full address space. You are always going to be running in some system where you have an operating system, or simply the overhead of the actual code itself and the overhead of the page tables required to manage your memory. Because of that, you are always going to be in an environment where you have access to less than the full address space. And when you're talking about a 32-bit operating system, the operating systems almost all exclusively reserve a minimum of 1 gigabyte for the system. When you're talking about 64 bits, the system is probably never going to actually use an entire, bit of address space between 2 to the power 63 and 2 to the power 64, but you're also never going to have a single allocation that will realistically fill 2 to the power of 63 bits of memory. And so overall, sign types are more than sufficient to actually represent the data, and they provide additional benefits such as you have the ability to represent sentinels via values like -1. So you can actually represent invalid data, much as you could using null for various things. You also can more easily handle cases like overflow, because you now have a clear sentinel to account for when overflow happens, because it wraps around to a negative value rather than just simply going back to 0 and therefore messing up your loops or other scenarios. And additionally, the JIT has specialized support for understanding when some types of when some properties return a value that is never negative. It does this for things like span, etc. And so it also has the ability to understand that for simple loops, when you do something like for in int I equals 0 as long as I is less than length, well, if it knows the length is never negative, then it knows that I can never be negative, and so therefore it does all the unsigned optimizations anyways. So using sign types is just it is essentially purely better from most perspectives. There's some high perf situations where you can get different code gen, but they don't typically matter, and you can manually optimize them where required.
Sounds good to me.
Tanner, when you were talking about the indexing stuff,
We then have the go ahead.
Sorry, I was just gonna say, when you're talking about the indexing stuff and slicing, do we want to talk about the indexing notation with slicing, or should I wait till we get down to slicing for that too? I can't remember what we decided.
I think we can get to that when we get to the slicing here in just a second.
Okay.
Yeah. We then have the equality operators, which work just like span. They do not do a deep sequence equals type equality. They just compare the references and ensure the lengths and strides are the same between them. We then have implicit conversion from array to span, matching the one that exists for T array to regular span. Based on adding the constructor overload above that takes a span, we should probably also have an implicit conversion from span to span ND. And then, of course, we've got the implicit conversion from span ND to read-only span of ND.
Yeah. I don't know if here or slicing would be the right time to ask the question, but in my mind at least, once you have a multi-dimensional span, you might want to get a single-dimensional span, so let's just call it a row, but I don't see a way to do that on this shape. Is that
Yeah, so
purposeful?
That is one of the things that's kind of called out at the bottom and that I called out earlier, where in order to successfully return a span, there are some cases where that's not possible today just due to span being limited to 2 billion elements. That may be a reason why we need to expose native span. But additionally, there's in general a case where you may want to effectively reduce the number of dimensions until you're down to a single dimension, and you basically operate over those single dimensional pieces of the overall view. So get a single row out, as you put it. We know that there's a need there. there's a set of APIs related to that we aren't 100% positive on the shape and name we want to do. And we know there's going to need to be a second API review in the space to cover those, and so we're going to want to bring that API as part of that second review.
Okay.
But typically, that type of behavior would fall under the slice category in other, multi-dimensional tensor whatever frameworks. So yeah, that's typically where that falls.
Fair enough. And there's something on memory marshal or unsafe or some other there be dragons type where you can pass a ref t and a length for a span, right? Or do we only have the single ref t?
Yeah, so there's two unsafe APIs that exist on memory marshal. One is getting the reference to the data, including if the span is empty. So it's just an incredibly quick but unsafe way to get a ref no matter what. Whereas get pinnable ref will throw if it's empty. And the other one is create span, which allows you to create one using a raw ref. So it's effectively equivalent to the void pointer overload, but it's hidden because we can't expose a constructor that has the name unsafe and all of that shenanigans.
Right. So with the shape right now, someone could build the span of a row themselves by using the ref indexer and passing the length they want based off of that.
Yes.
And now they have a linear span of t. Okay. I'm not saying that's a good long-term design, but it's
yes. And so if
possible.
they wanted to get really, if they wanted to get really fast with the prototype, that's what they could do.
Okay.
We then have the same set of APIs that are exposed on the core span system.span type, which is clear, copy to, fill, get enumerator, get pinnable reference, slice, and try copy to. All of those should be identical to the existing ones except for slice. Slice is different because we're working with multidimensional data, and so it needs to be defined a little bit differently. So in particular, for slice, there's kind of two concepts here. One of which is you want to be able to slice basically given a you basically want to say start from this row and this column and then slice the rest of the data, whatever the shape is, to the end. So you're basically providing the start for each dimension, the starting point for each dimension. And then the other one is you want to be able to slice out a range. So you want to say slice starting here and give me the range. And for range, you need to do additional validation to ensure that you didn't define something that's, nonsensical for the total shape. With range in particular, you start getting into a little bit of nuance that Michael hinted at earlier, and I'll let him talk a little bit more about it, where for example, you might want to say something like, I want to get I want to provide a range for the first few dimensions, but I want to provide just an index for one of the dimensions effectively. Because you might be saying, and what other languages use that to mean is to mean if one of those things provided as an index and the rest of them are ranges, then the index is implicitly treated as a range starting at that index of length 1. So it allows you to effectively reduce the number of dimensions. And then there's this other concept that comes into play where you can, when you're slicing ranges, you can not specify all dimensions. The other dimensions are implicitly interpreted as include the entire length, effectively. But I'll let Michael talk a little bit more about the nuance here, and what we're doing in the prototype implementation.
Okay, thanks, Tanner. Yeah, so there's a lot of nuance around slice. This is probably one of the more nuanced areas, I would guess, anyways, in this. So first off, the first thing that Tanner mentioned when he was talking about having ranged or indices passed in, the way that now a lot of these frameworks are in Python, right? So they're dynamically typeless. So you're right, they have a lot of flexibility in some of those areas. But if you pass in a range, it keeps the dimension. So if you have a 3x3 and you say like I want a range of 0 to 1 and 0 to 1, it'll give you back a two-dimensional subset of the 3x3 tensor. If you say I want to take a slice, but I want 0 as the first parameter and then 0 to 1 as the second parameter, it knows because the first value is a single index instead of a range, it basically drops that first dimension that would be of length 1 anyways, and so you get a single dimensional subset back instead of a multi-dimensional subset back. So the number of elements that come back, right, is the same, points to the same memory, but it's essentially like a tensor of length 3 versus a tensor of length 1 comma 3, right? And so that's one of the nuances around slicing that we don't currently have represented because we don't really have a way right at the moment to be able to switch switch between the index and the range on the fly like that. The other nuances around it when we're talking about implicitly determining the rest of the ranges that need to be in there, say that a lot of the times you'll use this to represent like images, right? And so you'll have like a 3-dimensional tensor, and then you may say, hey, well, actually, instead of having one image, I'm going to have a batch of 10 of them. So now you've got 4-dimensional tensor. You may not care about all those dimensions, and you don't want to have to know what all those dimensions are. And so you can say, like, I only care about, right, the first dimension. Instead of giving me 10 images, only give me 5. And so you'd say, give me 0 to 5, and then pass in no other dimensions. And it implicitly assumes that you're getting, the entire range of all of the other subdimensions. There's also the reverse where you can say, starting from the end, these are the dimensions, and all of the ones that come first are just implicitly assumed to mean the entire range of those dimensions as well. So those are kind of the nuances around slicing that we run into with span NDs and tensors.
Semi-related, I have a question kind of related to like splicing and like index start and end and all. Like let's start with the range, native range dot all. Is that just like an int dot min value and max value for start and end? Or is there like another way that's represented?
That would be start of 0 and end of from end 0.
Okay. From end. Where's from
Because
end?
index supports from start or from end, where from end is internally represented as a negative number.
I understand the representation. Okay, that makes way more sense. I thought is from end was like some sort of flag to let you know if it was like the static end index. The fact that it's done the way it is makes a lot more sense. All right, thank you.
End was hat 1, not hat 0.
What does that mean? Hat 1 versus hat 2.
Yeah, you're right, because hat 0 is length and hat 1 is length minus 1.
Yeah.
Got it.
So.
And hat being the like caret.
Yeah. So native range dot all is just native range's version of 0 dot hat 1.
I got it now. Thank you. I was just like confused on how that was represented. Okay.
Okay. Copy 2. Copy 2 succeeds as long as destination dot linear length is at least span linear length, and it copies positionally. Sorry. Do they have to have anywhere near the same
right,
shape?
So
is the question.
The way that the way that regular span works is simply destination has to be larger than the source. The way that copy to here works is conceptually similar. So the rank needs to be equal. And there's actually some discussion. There's some separate discussion points over implicit broadcasting and how it would function there. But the simple way to explain it is that the given the same rank, then the destination lengths must be greater than the source lengths, and it therefore operates as if you called destination.slice using the lengths of the source, and therefore making it the same shape. So you could copy a 3x3 into a 10x10 because the 10x10 could be sliced down into a 3x3.
But you can't copy it into a 1x9.
Right, because the shapes aren't compatible then, and we wouldn't know what to do.
Okay, so if somebody wants a for each ref address copy thing, they get to write that themselves, which is it's fine.
I think the only
Right.
caveat.
And what's not covered here today. Go
for it,
ahead,
Tanner,
Michael.
sorry.
I was just gonna say the thing that's not covered in the
Tanner, you're up.
Yeah, Tanner and I
think
seem
there's
to
a
have
delay
about a
between us
4-second
talking.
latency between us. This happened last time we were meeting with him and I.
Okay. Jeremy said I'm up. So the other the thing that's not covered in the proposal today, it's part of the more advanced operations called out at the bottom that we need to cover in the second review just due to 2 hours not being enough, is that there is going to be APIs for reshaping a span. So in particular, taking something like a 3x3 and redefining it as a 1x9. Some languages do allow you to do things like copy to a 3x3 into a 1x9, and it will implicitly reshape for you. .NET tends to be more explicit about things, and so my default presumption was that we should continue to be explicit about that, and we should require users to make the reshape themselves explicitly. There has been some discussion point amongst users, especially users who have more experience with tensor types and similar data structures in other languages, on whether we should do implicit anyways. And so that is a little bit of a discussion point that we will probably get to in the next review. But the current stance and the more flexible stance, because we can relax it later if we deem it appropriate, is that users would need to manually reshape the destination if these shapes were not compatible.
Okay.
Michael, you can go now. Sorry.
No worries. No, I was just gonna say I think the only caveat with the copy stuff is that right now, anyways, and we can change this, but in the prototype, the dimensions were also considered compatible if you had like a 1x3 or just one that had a length of 3. So if any of the leading dimensions were of length 1, it ignored those because those don't effectively change the shape of the underlying data. And so if you had like 1x1x1x5 versus 1x5, you could still copy them back and forth between each other because the actual like underlying shape was the same. Like I said, that was in the prototype. We can change that, but that is the prototype behavior with copying.
Yeah, and that one we said is fine because it's kind of like the dimensions of length 1 are kind of like leading zeros in a number. 1 and 0, 1 and 0, 0, 1 are all the same.
Yep.
It's just implicit data that you can explicitly specify or not specify.
Yep. I was just calling that out because if you said like, does rank of span 1 equal rank of span 2, it will return false. but it would still allow the copy. So it's the length of the rank, the length of the dimensions that actually matter is what it cares about.
Is there a desire to like reinterpret the number of dimensions without copying? Basically reduce the number of dimensions?
So I think we're going to talk about some of that
yes.
in the next review. Yeah, I don't think we have enough time to go over those APIs today, but we do have APIs around all of those types of behavior.
And another crazy like implicit conversion question, which I'm sure is bad, but I just wondered if you thought about it. Because you're talking how in Python with the slicing, you can just like pass ranges and indexes to the same slice method. Would you ever like have an implicit conversion from an index to a range of length 1?
So we have talked about that. We haven't made any decisions on that because in Python, in NumPy and in PyTorch, right, the two big Python frameworks for that stuff, passing in an index inherently behaves differently than passing in a range. So even if you pass in a range of length 1, the outcome will be different than if you pass in an index. And so depending on how we want to approach that behavior, right, we could have some type of conversion between index and range. If we did that though, we would lose the ability, if we wanted to have a distinction between a range of length 1 and an index. So we would need some other type of or we would need some other solution. I don't know what it would be, right? I mean, just, you know, spitballing, you could have a third type or right, whatever it may be, right? You would need some other solution if you wanted to have both go in, but still keep the differences between an index and a range of length 1.
Out of curiosity, like why do you want to know the difference like in an API that would take either thing? Like
yeah, so say that you had a 3x3 array and I said I want 0 to 1 comma 0 to 1, right? I'm getting one element back. It's the first element in the array or in the matrix, right? It would still be a matrix of shape, you know, like it would be a two-dimensional matrix with 1 in each, right? If you passed in 0 comma 0 dot dot 1, it would give you back a matrix of length of 1 dimension, because the index tells you that since it's only a single value, you can drop that leading dimension that's of length 1.
Got it. So indexes reduce dimensionality when ranges do not, of like, or the dimensions of the output of the slice.
Yes, so that's the behavior in
exactly. And
yeah. Sorry, Tanner, go for it.
Yeah, and in particular, this matches conceptually to how collection types already work. Slices take ranges, and slices return the original type. So if you slice a span by passing in ranges, it returns a span. But if you index a span, it returns a T. So in the same way, using an index reduces the dimensionality from a one-dimensional span to a scalar, which is theoretically 0 dimensions. Whereas slicing preserves it as a span, even if it contains one element, and therefore keeps it as one-dimensional. So
Yeah,
it's just taking that same concept and expanding it up to multidimensional data.
Yeah, I'm guessing it's common in the domain, but I didn't expect that from slice. Like I kind of assumed that even with like the indices overload, that you were keeping all the dimensions from the original span. With the range overload, you always do, right? Like no matter how many arguments there are. Whereas with the indices overload, for each index you provide, it's reducing 1 dimension or like 1 rank. Am I understanding that? Okay.
Yeah, right, and correct. In particular, we might not have the slice API work in that particular way. We might have slice work like you expect slice to work, and there could instead be an indexer that works with this type that allows either index or range in each for each parameter. And the indexer potentially with language support would operate in that way. But that's one of the things that we have to discuss with the language, and we have to finish figuring out the design for before we bring that part to API review.
Yep.
Okay,
Yeah, because
so
we
I was gonna,
Sorry,
with the
Drew.
current shape, then is there anything that takes a cube and gives you a plane out of the cube? So turns your
Not with what's
three-dimensional
covered
thing
in the
into a
API
two-dimensional
proposal
thing.
today.
Okay.
Wait, the slice with one index would give you that, right? Like based on what you said, it would take the three-dimensional down to 2.
Yeah, at least that's my understanding of that, Tanner. Is that correct? Or
Yeah, yes. Well, that's one of the ones where we've not fully determined. The slice API that exists on span. Of course, that's only one-dimensional data. It still returns a span with one dimension, even though it has the overload that takes in just a single index for the starting point. The slice API here that takes indices should likely be the same way, where it returns, where it preserves the dimensionality. And so even if you're only providing indices here, the slice API should still return a 1 by 3 rather than just a 3. And so it should still return a 2-dimensional slice. And then we would likely need a separate API that explicitly differentiates between the two, likely the indexer, since that's the thing that currently allows reducing dimensionality conceptually for existing collection types.
Okay. So right. So my understanding of that, and I'm just restating it in different terms to see if I'm right, is Python slicing can change rank, .NET slicing preserves rank.
so this is where we had a bunch of discussions back and
So
forth about
the
it.
Python language syntax.
Go for it, Tanner.
Sorry, go ahead, Michael. Okay, I guess I'll go. I was just saying, in particular, the Python language syntax allows slicing. And I imagine that the C# language syntax will come down to what LDM decides when we meet with them in a couple weeks. But the named slice API in .NET should, yes, operate like you've said in preserving dimensionality. Python does not have a named slice API like that. They just want you to use the syntax.
Yeah, which is index or syntax. And so we actually looked at doing a slice with the index or syntax, but we're waiting to meet with the language team to see language support for some of that stuff, because then we could have all of that same functionality with reducing of dimensions with the indexer, so it matches existing collection behavior. But because you could pass in ranges or indexes or whatever, you have the same you could have the same syntax but differing behavior like that.
Okay. More of a shape question. So, Emo, you can wake up now. Since params is easier to work with, I'll say now, even though I don't think we actually have the compiler that does it yet. For cases where we don't want 0 argument inputs to work, should we give a mandatory scalar value before the params, and then I guess you still can't recombine it to get into one helper afterwards, because we don't have like a span prepinned, because that would make no sense. Alright, so I think I convinced myself, while the shape, it would be nice if we had a index 0 formal parameter. That would make it impossible to use, so never mind. Moving on.
We could maybe ask the language for a feature where we can basically say like require 1. That way the language basically knows, even though providing an empty would otherwise be allowed, like block it, because it doesn't make sense here.
Right. I mean, you'd still be able to formally call it with, read-only span native index.empty because it won't know, but
Empty.
it would be nice if the param syntax, or if you otherwise had a span that happened to have length 0. But it'd be nice if we could tell the param syntax 0 is not allowed.
I think that's already the way it works for arrays.
Although in this case it should be unambiguous.
Right now, because
in this case,
the slice
we've
has
got two params overloads, it should block it anyways.
Right, because it wouldn't know which one to call. For params array things, Stefan, I don't think it does magic. I think it's we always overload it to not include the params, and so if you specified nothing, you'd get the one that just didn't specify it.
Sorry, I'm not sure I'm following. We're talking about having like a params indexer and like what happens if you have open bracket, close bracket.
Right. We fixed it because we added the other indexer, so it's now a ambiguous method invocation. But, right, because we added the native.
Yeah, I understand that part.
But without that, you would be able to be, like that's
I'm pretty
illegal.
Sure you can't
Call
like
it's param 0.
Can you click on the link I put in chat? Like I don't know what's up with Shark Lab. It didn't seem to have the param span in the main branch, but like with array, I assume it's the same deal, and you just can't pass 0. Like if you pass something in, it works, but if you don't pass anything, it breaks. Anyway, yeah. So if you add like a string to there, it will start working, even though it's like like the CS0443.
Fair enough. I mean, that may be true for the indexer syntax, but
right, it's definitely not that way for method calls. It is interesting that indexers are different.
Yeah, so I mean, the indexer language syntax may just be special, but like. What did I even do? Oh, because request headers was your object, right? So that foo. I don't know why it keeps selecting all and erasing. Yeah, so params to a non-indexer, 0 is legal, but apparently to an indexer, it's not. I don't know that was intentional.
It probably looks too much like a type declaration. I bet you it was. Yeah. But yeah.
Yeah, it's probably like, you can't define an array here. Like, that doesn't make any sense. But here in the slices, if we didn't have an overload, it would have been legal to call it empty. But the fact that it's not, or the fact that we do have an overload means we don't actually have to ask for a language feature on this one. But it is a thing that I think may come up.
Well, and
with our
in this particular case, slice with nothing should just be the identity operation.
Yep.
Yeah, because you said words about what happens if it's
span works
shorter.
Already.
Yeah, in either case, whether ranges or indexes, it would be basically no up, but or it would return the copy. But actually, the slice isn't copying or anything, right? It's just a projection.
That's correct.
Yeah.
Yeah.
And we did decide that the index overload is going to reduce dimensions of the output, even though it's called slice.
No, we said that the slice API wouldn't, because it's explicitly named slice.
Okay, sorry.
And that we would wait for the language decision on how to support what's commonly referred to as squeezing. which is removing dimensions of rank 1.
Yeah, I think
or
it's good.
Length 1.
Yeah, that slice keeps the original dimensions in all cases.
Then there's just a small comment of, do we want an explicit array to array to mirror what span has? I did not have a strong preference here. I was leaning towards no and wait for users to ask for it if they really wanted it. Especially because the span tracks an inint, and to array could theoretically fail if it was more than 2 billion in any dimension.
I mean, worse than that, it's because while there is a maximum index for array, there's also a maximum single array allocation size, which is still, I think, bound by 2 to the 32. Right?
Yeah, that might be the case.
Like if
Yeah,
you
it
have
might
a
be 4 billion is the max total dimension count.
right, so a long array can't go up to int dot max value minus 7 or something. It's like it can only go up to int dot max value divided by 8 minus 7. The minus 7 might be on the other side, but like I think that an instance of system.array is bound by 2 to the 31 bytes if it's reference types. That
Yeah, I think that's right.
I guess reference types means it's you get that divided by 8, but yeah, so leaving it off
There's
is
a little.
I was just going to say that I think I'm of the opposite opinion. I think it'd be good to have a to-array method, and that's just because when you're taking slices of things, right? So say you have like a 10 by 10 and you take a slice of 3 by 3, right? You may want to get those 3 by 3 out in a contiguous memory alignment, whatever you want to call it. And so right now you could do that. You'd take a slice and then you would copy it to a new span ND that was backed by an array that was all contiguous, right? And it would copy just those sub-elements. But there are times when it is nice to take that fragmented, n by n, whatever, and turn it into just a single contiguous array. And maybe we just want to say, like, you just have to slice and then copy to a new span ND and pull it out that way. But there are times when that would be useful.
yeah. I do wonder if full flattening. So when you talked about copy 2 supporting partial rank reduction or whatever, if the rank was, or if that dimension's value was 1, I wonder if having a copy to just a span, like not a single dimensional span, if that would always make sense, because it can be written in terms of the enumerator. Like, you say, I want you to copy to this linear destination, and it's like, well, okay, I have an enumerator, that means I have a linear way I can walk it. So, sure. And then we wouldn't need the to array in the beginning.
And that's kind of.
Go ahead, Tanner.
Yeah. So I agree that having APIs like flatten and copying to a linear span are goodness in the context of the overarching thing, and some of that's part of the API set we'll review next time, which includes and these are not the names we're taking, we're workshopping the names a little bit, but in other languages things like flatten, squeeze, unsqueeze, permute, etc. We're going to want those for copying to a linear span. I would personally lean towards, instead of calling that copy to, calling it explicitly flatten to, like flatten or flatten to or something like that, to make it explicit that you are reshaping the data as part of this copy operation.
Yeah, I mean, that makes sense to me. I just think that there are use cases where we need that ability. So that's how I was thinking with to array. So whether it's to array or whether it's something else doesn't really matter.
Yeah.
Because with whether it be copy to span
the
or
main
flatten,
concern over just calling it to array is
Go
These
ahead, Mr.
delays are
Laggy.
terrible. Go ahead, Jeremy.
I was gonna okay with a flatten or copy to a span and the linear length property, you can say t bracket equal new of linear length and then copy to your array. So and then you can make that an extension method if you really want. So the copy into existing memory I think is more important than the allocate to array one.
Yeah, I was going to say basically the same thing, and then just note that the main concern I have over exposing just to array by itself is the fact that it's an API that in most other cases can't fail, but in this particular case there are scenarios where it could fail, not just due to but due to the target type can't represent this data, and so I would want to make that fact just a little bit more explicit if we were to expose it that way.
All right. So all right, so flatten to, copy to, flatten, splat, squash. I mean, what does anybody like here? And please don't let it be splat.
Splat, I think we have to reject right out because splat is another name for broadcast, effectively meaning take the data and repeat it along each dimension to fill the fill the destination.
I would probably say flatten to or copy to. Flatten by itself to me sounds like it could also mean something like too dense or too dense, right? Which just removes all of the values. Not removes, but like if it was like a, if you took a slice of a 10 by 10 to a 3 by 3, it would copy that 3 by 3 slice to something else. That's how I would also read flatten. So I'd say either flatten to or copy to, but not just flatten by itself, personally.
Yeah, and I'd say the same. I have a preference towards flatten to just because it makes it explicit you're reshaping as part of the copy operation. It's basically, if we were to name this verbosely, it's flatten and copy to is basically what it's doing. I would want the API just called flatten to return a span ND, or return a tensor of t instead, and therefore be explicit that I'm taking the current instance and I'm returning a new thing, whereas flatten to instead implies I'm doing the flattening operation into a target thing.
So I prefer flatten to over flatten. I think I prefer copy to still, because like what else would it do? And like what if it was one dimensional to begin with? It could be, right? So it's like, I don't know.
Yeah, I personally
like, is there
feel
any other reasonable way of copy? Sorry.
I feel that copy to is unambiguous unless you think that there would be other overloads of flatten to in the future of accepting the you're a different span ND with the same total length but a different shape, but I'll make it work. Or if the only thing it's gonna have is the linear span, whether it be span and native span, I would rather those be copy to overloads instead of a new verb, personally.
My concern there would be that if we have copy to span, and that works with going from any dimensions down to one dimension, then people might expect, for example, a copy to 3 by 3 to work as copy to span ND, where the span ND is a 1 by 9. And therefore, because that is effectively a flattened span, they would expect it to now work. and we had originally said we don't intend that to work. We intend for users to make the shapes match, and hence the flatten makes the I'm reshaping this and then copying more explicit.
Fair enough.
Wait, so people will think that one-dimensional span ND and a normal span are compatible if we call it copy to? That's the argument?
They might expect the two overloads to behave similarly. So they might expect so we're saying that for a 3x3 span ND, we want copy to span to work because we know span is explicitly one dimension, and so it should work for anything that's at least 9 total length. But then they might expect for copy to span ND to work the same way, where you can successfully copy from a span ND of one shape to any span ND of another shape, provided that the linear length at least matches. But that gets into confusing questions on how do you copy the data in, and it doesn't work quite the same as slice copy to. So I think there's potential confusion and ambiguities and pit of failures users can get into, and we could normalize that and make it consistent and make it work. But I'm not sure that's going to be obvious to users as compared to an explicit separate name that makes it that makes it more clear as to what's happening. And so I think copy to requiring matching or compatible shapes is what we want, and then flatten to is the thing that we can basically make it clear this is flattening and then copying, and therefore it can be understandable that it works when the shapes of the two buffers don't match.
Okay, and with the copy to span ND to span ND, we were talking about this earlier. The thing you're copying to could have lower dimensionality, but it basically has to fit. You're not like flattening, like you're not like, putting one row at the end of the other. Like you'd have to have like a single row. Yeah. Okay. I'll buy it. I'm okay with flatten too, personally.
Yeah. So it's they have to be a compatible shape. So like a 3x3 can go into a 10x10 because a 10x10 can be sliced to a 3x3. A 10x10 can't, however, be sliced to a 1x100. That ends up having to be an explicit different API, which is called reshape, which is going to be in the next review.
Okay. I mean, some other words would be export, extract.
Linear copy to. I mean, we did call it linear length. I don't know.
And Emo, I think you're the only English as a second language who's been talking. How do you feel about flatten to here?
I mean, flatten is pretty common, so I don't mind.
Okay. Just making sure it's not giving you a what the hell are you guys even talking about type impression. So.
Well, I mean, the problem with flatten in general is like it's very domain specific of what you think it will do, right? So like, I think that to me is my bigger concern. I think is like, unless you're breathing tensors, it might not be obvious what flatten means. Like in the context of collections, you would expect basically the semantics of select many, right? It just becomes one stream of elements basically. But
yeah,
I mean,
just
that's
not
kind
add
of
any
what.
callbacks.
Okay. And it's pattern enumerable. It's fixable. Do we want try flatten to mirror
Try flatten.
Try copy to, or do we just want people to call it themselves?
I think try flatten to make sense for parity, especially since it's a 2 operation. And since span might not be large enough to hold any linear length. If we have native span, then I might say maybe wait till people ask, but in particular, since it definitely can fail, it might not be large enough and things like that. I think the try definitely makes sense.
Okay. And the enumerator struct is not read only because it moves next.
Yep.
Okay, and then
read only span should
be the same without fill.
Read only span should mirror span except without fill and without clear.
Yeah.
It's worth noting that we opted for span ND here. We did actually discuss whether or not we wanted to have explicitly numbered dimensions like span 2D, span 3D, span 4D, etc. for the most common dimensions, potentially as a form of optimization. That was turned down for kind of 2 reasons. One, that's a lot of additional types that aren't clear if they are going to be that beneficial, and which hinder writing generic code that works over arbitrary size data, particularly when you're doing things like, well, I've got a span of unknown dimensions. I need to go to a span of unknown dimensions -1. That gets kind of complex. There's community prototypes for providing things like const generics. So like you might be able to have a span and a span of t comma int, where the int can be an integer literal representing a constant. There's just a lot of general open space there, and we opted to say we're only going to go with the arbitrary dimensioned types that are effectively the root that work with anything. And we will discuss more in the future, including with the language team and the runtime team, what direction we want to take for if users do want to have more strongly typed multidimensional concepts in the future.
Okay. So, yeah, the thing I don't think we've landed on, and I don't think we even had enough of the right people in the room, is the name of these things. The easiest thing, aside from the ND, is the types in .NET usually don't use suffix differentiators, right? So we have list, and then we have linked list. It's not list linked. And so an n-dimensional span, the English phrase for it is n-dimensional span, not span of n dimensions. And you have to throw in the of to make it work as a suffix. So maybe we'll think that this is worth breaking our normal rule on, but I won't go so far as to say I hate it with the passion of 1,000 fiery suns, but like it's pretty darn close to that. It's a bad name.
So the main reason that we ordered, the main reason we did it this way is because if we were to actually do this as strongly typed dimensionality, we would do it as a suffix. So we would have span 2D, span 3D, or we might have just called it span 2, span 3, much as we've done for things like vectors or various other types, int 32, int 64, int 128. And so when it came down to matching that pattern, we basically said, well, what can we replace 2 with that makes sense? And that basically came down to M or N. That wouldn't make it completely ridiculously too verbose to type. Even read-only span people think is too ridiculously verbose to type sometimes, and they wish we had just done RO span. That's a common thing that comes up in various forums, both for beginners and non-beginners alike. And so we opted span ND as the favorite amongst everyone who gave an opinion on it, and that's why we did that route, rather than something like MD span instead, or multidimensional span, spelled out more explicitly.
Mm-hmm. Yeah, I mean, I see how we get there. It feels bad to
Yeah,
me.
and I definitely understand why there's the non-like for it and how it can be confusing.
But I'd want a minimum to hear, I don't know, at least Tobe, but really just getting a lively discussion instead of, the crickets that we had.
Yeah.
So
Notably,
procedurally,
Stephen has been involved in all of the discussions and design talks up to this point, so he's very much aware of the name for span ND. I can't obviously speak for whether he actually likes it or not, but
right. Or was hoping that
he didn't,
one of us would come up with
outright
a better
reject
name in
it as
this
part
meeting.
of the discussions.
Yeah. Yeah. So procedurally, I think we're probably content enough with native index and native range, because they would just take what we have and stick the word native on the front. But then with the caveat of conversion to and from the old thing. I did look. We don't. Yeah, the book doesn't have anything written about checked because we didn't have checked operators at the time. But it does just have the to and from names for if you have a conversion operator. That's what the named version is. We don't need the from because it's a constructor. So I think this is the right shape.
The only thing I'm not sure is, do we really want to put it in system? I know that's where index and range live, but index and range are probably used by a lot more people, and it's not that many to begin with. That I'm not sure we want to put these guys there, but to be honest, I don't know where else we would put them.
System numerics would be the next closest thing. I don't think we'd want to hide it off in system numerics tensors, though.
No,
so
I don't think
I
it
would think
belongs
system
there.
or system numerics is the right place.
Numerics might be a place to put it. Like I was thinking something that has to do with native, but I couldn't think of anything that, because I mean we don't want to put it in interop. That's not the great place for these things. But I think numerics is probably reasonable.
Okay, so Emo wants to have more people in the room to discuss the namespace.
Well, I mean, at least I would say, take it as a feedback item, like consider moving it somewhere else. And if you can come up with a good place, that would be good. Like system is already very crowded, right? We don't want to put
Sure.
stuff there that is very, very
No.
narrow.
You wanting a further debate on the namespace makes it easier. That for Tanner to break this into multiple issues, because we don't have a good way of approving half an issue. So
I see. Well, I mean, yeah, we would just say it needs work, I guess.
Right.
We do notably want to get this. We've got a prototype of a lot of this already, and we are wanting to get it out to users as part of the preview going out at build.
When does that lock down?
It's in a preview, so it's experimental, and we'll obviously update it to be whatever the 23rd.
So already.
I mean, if we get it, one thing we could do is we could just say, okay, we look at it next Tuesday again, and then we approve it, right? With some changes. That would be one way to do it.
And it's of course going to be previews, so we'll update based on whatever API review makes this the final decision, but we want to get the general shape out to customers' hands, that way they can give us the feedback and everything. And
Right.
build the preview going out build is the one that it needs to be in for that.
Like, in fairness, I'm curious like how Jeremy feels about this, but like this is not an API where I would be super concerned if we would change our mind after build and rename it. So if we can't agree on a name now, and we need one more time thinking about it, then so be it.
I think that the 10 people who would use this between build and release are probably willing to fix their code.
Yeah, I don't want to sound dismissive, but I mean,
as
it's probably
part
more
of
than 10
this,
people, but it's probably not going to be hundreds. So, yeah.
I don't know how many people would be
as
using
part of
preview builds
this,
and understand what they need to understand to use this type at all. So it's special. All right, go ahead, Mr. Laggy.
I'm not sure what's wrong with the lag either, because I normally don't have this issue, but the past couple meetings with Michael have had it, so
It's
not
my
sure.
fault.
But anyways, what just touching on this same thing, and because it was brought up, what is the vague API review feeling about native span? Do we want me to create an explicit proposal about that and bring it forward because of the known limitations of span, or do we want to have a deeper discussion with and do we want to have a deeper discussion as part of that with Jan and others on whether it needs to be a separate type or update the existing span of T?
Yeah, I mean, that's more a discussion for Jan. Like, my general concern is I think we don't want to fuck with the performance of that type, so we don't want to attach things to it that might make it slower, because it is meant to be, super, super lightweight compared to the metal type. And so if that means some more cognitive load on people on top of that, I think that's probably acceptable. In which case, yeah, we need to come up with a name.
Yeah, I mean, reusing or growing span to work off of links longer than int 32, really int 31. Like that means we'd have the length and long length, and for the first time ever, we need to decide what happens to length if long length is too big.
Right.
And if that throws, that probably makes span unusable. And if it doesn't throw, it probably makes long span unusable, which means it's probably going to have to be a different type. But I don't know.
I mean, my general concern is like the
Who the
devil's in the
talk on that
details,
is.
right? Once you actually do that, like, I mean, if you look at arrays, for example, they munched it together, right? And it's like, is that a better world?
Right,
Probably not.
But
Right?
I don't think it matters. I don't think there's ever a legal array in any current version of the CLR that length couldn't answer the length. Like
Right.
we've never made one that long length or that has a length bigger than 2 to the 31.
No, we do actually multidimensional. You can totally create arrays where length will flow.
Yeah, multi-dimensional explicitly can.
Fair enough. But then you have to be using system.array itself, or no, because you can
No,
be
just the regular,
super all brackety.
Yeah, the brackety syntax of commas that will do it. But it's
then,
again, like
yeah.
this is a tiny fraction of our user base. It's
Yeah.
not super common.
So anyway, I mean, it's clearly its own discussion, but I don't know if it's how much of it's an API discussion and how much is a Jan discussion.
Yeah, it seems like what I would like to hear is that if we feel like that is something, I guess my point is, it seems like it's almost a constraint given to us, right? So either we can have the same type, in which case the naming conversation is pointless, or we cannot, in which case we need to come up with a name, right? So it's almost like, yeah, as you said, we don't make the rules here.
Yeah. Okay, so what I'll do is I'll open a proposal referencing, or maybe I'll just update this proposal to have a native span, which mirrors the name for native index and native range, because I assume we're going to use the same prefix for all three of them. I will loop Jan in as part of this and make sure that he's on the same page and that we are confident we can't update the existing span type. And then we'll move forward from there.
What does ND again stand for?
In-dimensional.
Oh, N
Number of
dimensional.
dimensions.
Yes. In stands for in.
Yeah.
D stands for dimensional.
'Cause I in the beginning I always read it as MD, like multi-dimensional.
Indeed,
guess.
I thought it was a typo.
Yeah.
Oh well.
And
Naming
that's
is hard.
span MD is what I had proposed originally, but there was enough people that were like, I don't like span MD, use N instead, that I was like, okay.
Well, if it's
And
span
that's what I changed the title
span
to.
MD, we'll just start calling it Doctor Span.
I was about to say I actually like that.
It's like, oh yeah,
Dr.
just
Span.
copy that into Doctor Span.
All right, guys.
All right.
It was fun.
So needs more work.
Needs more PhD.
Because of namespace discussion and then the element of degree that the span has, aka its name, and yeah, but that does let the whole issue go as one
Right.
terminal status or one coherent status. No, not suggestion.
Thanks so much, and I'll get things updated for next Tuesday if it sounds like we're doing that. We're gonna continue it then, and if not, we can schedule it for next Thursday or another time. Just let me know.
Sounds good.
All right. Well,
Bye.
thanks everyone
Bye-bye.
who joined us online. If your brain didn't melt, then congratulations, because mine certainly did. And we'll see you next Tuesday for either more of this or going back to the other things. Given that we still have 40 issues, I hope it's not going back to this and that we do this on Thursday, but we'll see. So, anyway, see you Tuesday, 10 a.m. Redmond time, our same .NET time, on our same .NET channel. Auf Wiedersehen.